Hello all, this is your Maverick here. Now we are going to discuss the important formulae and the concepts required to solve the numericals in the chapter Statistical Techniques. As of now, in Mumbai University, engineering students from Computer, IT, AIDS, AIML, CSE, IoT, Cybersecurity and related departments learn this chapter Statistical Techniques in their semester 3, Engineering Mathematics 3. Whereas students from EXTC, ECS, Electrical, Electronics, Instrumentation, Civil, Mechanical, Mechatronics, Automobile, Chemical, and all other departments learn this chapter in semester 4, Engineering Mathematics 4. In end semester exam, this chapter is asked for 19 or 20 marks. If it is asked for 19 marks, there will be a compulsory question for 5 marks, a question for 6 marks, and a question for 8 marks. If the chapter comes for 20 marks, there will be two questions of 6 marks in different sets, and there will be a question of 8 marks. This is the second part of the discussion of formulae and concepts, and the last part as well. Here we discuss fitting of first and second degree curves, regression coefficients, and lines of regression. So let's begin now. Straight line fitting or first degree curve fitting or linear curve fitting. Here our aim is to fit a straight line between dependent and independent variable. Suppose we have to estimate the value of y when the value of x is given. So in this case, we will say x to be the independent variable and y to be the dependent variable because we are trying to estimate the value of y when x is given. So x is independent over here and y is dependent over here. For this, the required equation will be y equal to a plus bx. Here a and b are some unknown constants which we will try to find out using the normal equations. Sometimes they directly give in the question fit a straight line y is equal to a plus bx. Sometimes they give a value of x, ask to estimate y. In either case, we will fit the straight line y is equal to a plus bx. To find the values of a and b, we use normal equations. Since there are two unknowns, we require two normal equations. The first normal equation is directly found by taking the summation of the required equation. So summation y, summation of a is n times a, then b times summation x. For the second normal equation, we multiply by the independent variable. And then take the summation of this. It will be summation of xy, a summation of x plus b summation of x square. So solve the normal equations simultaneously. To get the values of a and b, then substitute them and write the required equations. Now suppose to estimate x given the value of y, required equation will be x is equal to say a dash plus b dash y. So here also normal equations can be used to find the values of a dash and b dash. The first normal equation is directly taking summation of the required equation. So summation x will be equal to n times a dash plus b dash summation y. Then for the second normal equation, we just multiply the independent variable y. So it will be like this. And then we find the no, summation of this. So summation xy will be a dash summation y plus b dash summation y square. Now, once if both the lines are fitted, like y is equal to a plus bx and x is equal to a dash plus b dash y, using the coefficients of x, that is b in the first case, and in the second one, the coefficient of y, that is b dash, we can find the Carl Pearson's coefficient of correlation R. Carl Pearson's coefficient of correlation R is nothing but the square root of product of this coefficients, that is b into b dash. So R will be square root of b into b dash. Then R square will be equal to b into b dash. Now let's proceed to parabola or second degree curve fitting or quadratic curve fitting. Again, to estimate y given x, required equation will be y is equal to a plus bx plus cx square. Now, earlier it was a linear curve fitting or first degree curve fitting. So we went to up to a maximum of x to the power 1. But now, it being a second degree or quadratic curve fitting, we go from x to the power 1 also to x to the power 2. So we have one more coefficient over here, c, which is the coefficient of x power 2. So as we have three coefficients a, b, c, we need to find three normal equations and solve them. The first normal equation will be that is the summation of the required equation. Summation of y is equal to n times a plus b summation x plus c summation x square. To find the next normal equation, we multiply the required equation by independent variable, that is x. Xy is equal to ax plus bx square plus cx cube. Then we take the summation of this. Summation of xy is equal to a summation x plus b summation x square plus c summation x cube. Now to find the third normal equation, we again multiply by x and take the summation. So summation of x square y is equal to a summation x square plus b summation x cube plus c summation x to the power 4. When we solve all the normal equations simultaneously, we get the values of a, b, and c. Then we substitute them in the required equation and write it. So if suppose we have to estimate x when y is given. In this case, y is the independent variable and x becomes the dependent variable. Hence, the required equation will be x is equal to a plus by plus cy square. So the normal equations to find the values of a, b, c are as follows. First one, we directly take the summation of the required equation. Summation x is equal to n times a plus b times summation y plus c times summation y square. Then again, we to get the next normal equation, we multiply the required equation by an independent variable. Then we take the summation. Here the independent variable is y, so it will be xy is equal to ay plus by square plus cy cube. So taking summation of this will be summation of xy is equal to a summation y plus b summation y square plus c summation y cube. Next, again we multiply once again with the independent variable y, then take the summation. So summation xy square will be a summation y square plus b summation y cube plus c summation y to the power 4. When we solve the normal equations, we get the values of a, b, c. Substituting in the required equation, we get the quadratic curve or the parabola fitted. Now, there are chances that in straight line fitting or linear curve fitting, they may ask one line or both the lines to be fitted. But when it comes to parabola or second degree curve fitting, they will ask only one equation to be fit. Okay, either they'll ask y is equal to a plus bx plus cx square, or they'll ask x is equal to a plus by plus cy square. Now there could be one more confusion. Suppose in question if it is just given that fit a parabola for the following data. In this case, which parabola has to be fit? Whether we'll fit y is equal to a plus bx plus cx square or x is equal to a plus by plus cy square. If it is clearly not mentioned in the question, which variable is to be estimated or which is the given variable or not the equation, in that case, we always assume that x is the independent variable and y is dependent on x. So y will be a dependent variable. We assume that y is a function of x. In that case, when it is clearly not mentioned or explicitly not mentioned in the question. Same goes with straight line fitting. If which line has to be fitted, no clues are given or it not explicitly stated, then we will fit y is equal to a plus bx, assuming that x is the independent variable, y is the dependent variable, and y is a function of x. Now let's move to the coefficients of regression. They are denoted by Pyx and Bxy. First is the coefficient of regression of y on x, denoted by Byx. Byx is equal to r times sigma y by sigma x. When we simplify this, we know r is equal to covariance of xy upon sigma x into sigma y. Then, as per the formula, we multiply by sigma y and divide by sigma x. Here we can find the standard deviation of y gets cancelled, and we get the square of standard deviation of x, nothing, which is nothing but variance of x. This is simply covariance of xy upon variance of x, which is nothing but summation of x minus x bar times y minus y bar upon summation of x minus x bar the whole square can be opened up as summation of xy minus n x bar y bar upon summation of x square minus n times x bar square. When I multiply n into this, it becomes n times summation xy minus nx bar into ny bar upon, again multiplying n in the denominator, I get n summation x square minus n square x bar square. We know that n times x bar is summation x, n times y bar is summation y. So n square x bar square will be summation x the whole square. So substituting all these values, we get n summation xy minus summation x into summation y upon n summation x square minus summation x the whole square. Similarly, we write the coefficient of regression of x on y, denoted by bxy. Bxy is equal to r times summation x upon summation y, which is simply covariance of xy upon variance of y, also equal to summation of x minus x bar times y minus y bar the whole upon summation of y minus y bar the whole square is equal to summation xy minus n times x bar y bar upon summation of y square minus n times y bar square is equal to n times summation xy minus summation x into summation y the whole upon n times summation y square minus summation y the whole square. A few notes about the coefficients of regression and the coefficient of correlation. The geometric mean of the coefficients of regression, that is byx, bxy, is the coefficient of, or I can say is equal to the coefficient of correlation, which is R. That is, product of coefficients of regression is the square of the coefficient of correlation. Next, the absolute value of arithmetic mean. When I say arithmetic mean, I simply mean the mean or average of the coefficients of regression is greater than or equal to the absolute value of coefficient of correlation. By absolute value, I mean the positive value without considering the sign or simply the modulus. So let's take the mean of bxy and byx. The absolute value of this will be greater or equal to the absolute value of r. Or simply we can say the absolute value of the sum of the coefficients of regression will be greater than or equal to 2 times absolute value of r. The coefficients of regression and coefficient of correlation between the two variables will always have the same sign as they depend directly on the sign of covariance of between the two variables. If byx, bxy are covariance of xy. If byx is greater than 0, then bxy will also be greater than 0, r will also be greater than 0, even covariance of xy will also be greater than 0. If covariance of xy is less than 0, ry will be less than 0, bxy will be less than 0, byx will be less than 0. If suppose r is 0, then the regression coefficients also will be equal to 0, then the covariance will also be equal to 0. Either all are positive or all are negative or all are zeros. The coefficients of regression byx and bxy are independent of change of origin but not independent of change of state. Means if we multiply or divide all the observations in a data set by a constant, then the coefficients of regression may change accordingly. But if we add or subtract a constant to all the observations in a data set, the coefficients of regression will not change. Okay, now let's move to lines of regression. There are two lines of regression. Line of regression of y on x, line of regression of x on y. Lines of regression can be found in two ways. First is least square method. Least square method is the one which we use for straight line fitting. Here y will be equal to a plus bx, x will be equal to a dash plus b dash y. We use the respective normal equations to find the unknowns a and b. Later is that we can use the regression coefficients byx and bxy. Here it will be y minus y bar will be equal to byx into x minus x bar. X minus x bar will be bxy times y minus y bar. Here the slope of this equation will be byx. Here the slope of this equation will be 1 upon pxy. Suppose someone asks you to find Carl Pearson's coefficient of correlation R. So R will be square root of b into b dash. Here R will be given as square root of product of regression coefficients byx into bxy. Also, the coordinates of point of intersection of the lines of regression are their respective means. Simply x bar y bar, that is the means of x and y, is the point of intersection of the lines of regression. Angle between the lines of regression represented by theta is calculated using the formula tan theta is equal to 1 minus r square the whole by r times sigma x into sigma y the whole upon sigma square x plus sigma square y. Here, sigma x and sigma y denote the standard deviations of x and y respectively, whereas sigma square x and sigma square y denote the variances of x and y respectively. R denotes the Carl Pearson's coefficient of correlation. Okay, this is the end of all the concepts and formula required to solve the numericals in the chapter Statistical Techniques. Hope you all followed all the formula and concepts. Thank you all.